In this episode, we're going to connect two ideas that beginners often keep separate in their heads: where identity information lives, and how fine-grained access decisions can be enforced consistently. Most people can imagine a login because it feels like a single event, but the deeper challenge is what happens after login when systems need reliable identity data and repeatable policy decisions across many applications and services. Lightweight Directory Access Protocol, LDAP, is closely associated with directories, meaning organized stores of identity information like users, groups, and attributes, while Extensible Access Control Markup Language, XACML, is associated with expressing and evaluating access control policy in a consistent way. The reason these belong together is that policies often depend on attributes that directories provide, such as group membership, department, or account status. When you design security for a real environment, especially one that mixes on-prem and cloud, you need both a dependable identity source and a dependable way to decide access based on that identity. By the end of this lesson, you should understand what LDAP and XACML are, what they are not, and how architects use them to make authentication support and access policy enforcement less fragile and more governable. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A solid place to begin is by clarifying the difference between authentication and access policy, because LDAP and XACML live on different sides of that line. Authentication is about proving who someone is, such as confirming that a user presenting credentials is truly that user. Access policy is about deciding what that authenticated identity is allowed to do, such as which data they can read or which administrative actions they can perform. Beginners sometimes assume that if authentication is strong, authorization automatically becomes safe. But that assumption breaks quickly when you realize that a well-authenticated user can still be over-permissioned. LDAP often supports authentication indirectly by providing a place to find identities and verify credentials, but LDAP is not itself a policy language that can express complicated business rules. XACML, on the other hand, is not a credential store, and it does not replace the need for an identity system that knows who the user is. Architects use these technologies to reduce confusion. LDAP helps systems retrieve consistent identity attributes, and XACML helps systems make consistent decisions using policy logic. When you separate those responsibilities clearly, you reduce the chance that each application invents its own rules in inconsistent, risky ways. To understand LDAP, it helps to picture a directory as a structured address book that is designed for machines, not for humans browsing casually. The directory organizes entries, such as a user or a service account, with attributes, such as name, group membership, account status, and contact information. The power of LDAP is that it provides a standard way for systems to look up and query that information, even if the directory is used by many different applications. That standard query capability is what makes it so common in enterprise environments, because it allows central management of identity attributes while still enabling many systems to consume them. A beginner misunderstanding is thinking LDAP means the directory is automatically trustworthy and correct, but directories can contain stale data, misassigned groups, or accounts that should be disabled but are not. The architectural point is that LDAP is a protocol that helps systems read and sometimes update directory data, and its value depends on the governance and lifecycle processes behind the directory. In cloud and hybrid designs, the directory often becomes a source of identity truth that must remain consistent across environments, and LDAP-style access patterns influence how applications discover and use that truth. Another key concept for LDAP is that it is frequently used to support authentication workflows by helping systems validate identity claims. Some systems use the directory as a place to verify credentials, while others use it primarily to retrieve attributes after authentication has happened elsewhere. Either way, the common requirement is that the system needs a reliable identifier for the user and a reliable way to map that identifier to attributes like group membership. This becomes especially important when you want centralized control over access, because groups and attributes are often the inputs to authorization decisions. A beginner pitfall is assuming that group membership alone is a complete policy, but groups are usually a rough approximation of intent, and they can become messy over time as people change roles. Another pitfall is assuming that every application should query the directory directly, which can create performance and availability issues if the directory is overloaded or unreachable. Architects consider how directory lookups affect resilience, because if applications cannot retrieve identity attributes, they might fail open by granting access without proper checks, or they might fail closed by denying all access and creating outages. The correct behavior depends on the system's mission and risk tolerance, and designing that behavior is part of using LDAP safely. To understand XACML, it helps to focus on the problem it is meant to solve, making access decisions consistent and explainable across many systems. When each application encodes its own access rules in its own code, organizations quickly lose visibility into who can do what and why. Policy logic becomes scattered, hard to audit, and difficult to update when requirements change. XACML provides a way to express access control policies in a standardized form and evaluate requests against those policies. A typical policy decision considers a subject, such as a user or service identity, an action, such as read or approve, a resource, such as a record or file, and an environment context, such as time or location. Beginners sometimes assume policy evaluation is just a yes or no check, but in reality, the policy decision may need to incorporate many inputs, including attributes pulled from an identity store. The architectural advantage is that policies can be managed centrally and updated without changing every application's internal code, reducing drift and inconsistency. The constraint is that central policy requires careful design of how applications ask for decisions and how they enforce the results reliably. A helpful way to connect XACML to real system design is to think about the separation between decision and enforcement. XACML is most closely associated with the decision part, meaning evaluating whether a request should be allowed based on policy. The enforcement part is where the application or service actually blocks or permits access based on the decision. Beginners often assume that if you have a policy engine, enforcement is automatic, but enforcement still has to happen where the data and actions actually occur. If an application ignores the decision or misinterprets it, the policy becomes a suggestion instead of a control. Architects therefore treat policy evaluation as a service that must be integrated carefully, with consistent request formats, reliable identity context, and strong error handling. This is especially important in cloud environments where services are distributed and where latency and availability can influence whether policy calls are made correctly. A design must decide how to handle situations where the policy decision service is unavailable, because failing open can expose data, while failing closed can block critical operations. The safest designs match failure behavior to risk, often failing closed for sensitive actions and using controlled exceptions rather than silent bypasses. Now we can connect the two directly, because XACML policies often depend on attributes that come from a directory accessed through LDAP. For example, a policy might allow access only if the user belongs to a certain group, has a certain clearance level attribute, or is marked as active and not suspended. Those attributes must come from somewhere, and directories are a common source. This is where beginners often get surprised, because they realize that access control is only as accurate as the attribute data it consumes. If a user's status is wrong in the directory, policy decisions will be wrong, even if the policy logic is perfect. Architects therefore design attribute governance as part of access control governance, ensuring that group memberships and critical attributes are updated through joiners, movers, leavers processes and reviewed periodically. They also design attribute scoping carefully, because not every attribute should be shared with every application, and not every application should be allowed to query everything. In a hybrid environment, you may have multiple identity stores, and the design challenge becomes deciding which attributes are authoritative and how synchronization affects policy correctness. The point is that LDAP and XACML become powerful together when attribute integrity and policy integrity are both treated as first-class design concerns. It is also important to address a beginner misconception about what these technologies do in relation to modern token-based identity systems. Some learners assume that because many systems use tokens for single sign-on, directories and LDAP are no longer relevant. In reality, even when authentication uses tokens, systems still need a source of truth for identity attributes, group membership, and account status, and directories often play that role. Similarly, some learners assume that token claims replace policy engines, but claims are usually a snapshot of identity information at a point in time, and policies may need to consider context that is not safely embedded into a token. XACML-style policy evaluation remains relevant when you need centralized, updatable policy logic that can apply to multiple services consistently. An architect chooses how much to rely on token claims versus live attribute lookups versus policy evaluation calls, and that choice affects performance, freshness, and security. Freshness matters because access should change promptly when a person changes roles or leaves, and relying only on stale claims can delay deprovisioning. This is why governance and lifecycle connect directly to policy enforcement, and why LDAP and XACML remain useful concepts even in environments that also use token-based sign-in patterns. Another architectural consideration is performance and scaling, because both directory lookups and policy evaluations can become high-volume operations. If every request triggers multiple directory queries and a policy evaluation call, you can create latency that harms user experience and increases infrastructure cost. Beginners sometimes respond by caching everything aggressively, but caching introduces the risk of using outdated attributes, which can cause access to persist after it should be revoked. Architects balance these concerns by deciding which attributes can be cached safely for short periods and which require real-time validation, especially for high-risk actions. They may also design systems so that policy decisions are made at meaningful control points rather than on every low-risk request, while still ensuring sensitive data access is consistently guarded. Another common strategy is to minimize the number of attributes required for policy by designing policies that focus on stable, well-governed signals rather than on many fragile details. This reduces both performance burden and governance burden. In cloud and microservice architectures, these scaling decisions become even more important because services communicate frequently and access decisions must remain consistent without turning the identity system into a bottleneck. The architect's job is to ensure that the control remains strong while the system remains usable and resilient. Policy correctness also depends on avoiding ambiguity in identity representation, which becomes a challenge when systems integrate across boundaries. If one system identifies a user by username and another identifies the same user by an internal identifier, policy evaluation can become inconsistent unless there is a reliable mapping. This is where identifier strategy and directory design meet policy enforcement design. If a directory entry changes because a user's name changes, a stable internal identifier helps maintain continuity so policy decisions and audit logs remain accurate. XACML requests must use consistent identity identifiers and must include the right attributes in a trustworthy way, or else the policy engine may make decisions on incomplete or misleading information. Beginners often assume the application can simply tell the policy engine whatever it wants, but that creates a trust problem because an attacker could influence the inputs if they are not validated. Architects therefore define which attributes come from authoritative sources and how they are conveyed to the decision point. This is especially relevant in distributed systems where different services might supply different context. The high-level principle is that policy decisions must be based on trusted, validated inputs, not on unverified claims from untrusted components. A major reason to use centralized policy approaches like XACML is governance, meaning the ability to review and manage access rules as organizational needs change. Policies evolve because teams change, regulations change, and business processes change. If policies are embedded inside application code, updating them can require development cycles and deployments, which slows response and increases the chance that some applications lag behind. Central policy helps keep decisions consistent, but it also raises the stakes for policy management mistakes, because a bad policy change can affect many systems at once. Architects therefore design change control, testing, and rollback processes around policy updates so governance improves rather than worsens. They also design for explainability, because an access denial should be explainable in terms a reviewer can understand, and an access grant should be justifiable during audits. This connects back to directory data, because if a policy depends on group membership, reviewers must be able to see how group membership is assigned and approved. In cloud security contexts, governance also includes knowing which identities have access to which services and data stores, and centralized policy can support that visibility if it is integrated with logging and reporting. The idea is not to make access complicated, but to make it controlled and reviewable. Logging and auditing are where LDAP and XACML choices become visible during incident response and investigations. If an organization cannot reconstruct why access was granted or denied, it becomes difficult to determine whether an event was legitimate or malicious. Directory access events can reveal when attributes changed, when accounts were created, and when group memberships were modified, which can be crucial when attackers try to add themselves to privileged groups. Policy decision logs can reveal which policy rule allowed an action and which attributes were used, helping investigators see whether an access path was intended. Beginners sometimes think of logging as an afterthought, but in identity and policy systems, logging is part of trust. Without logs, policy is not provable. Architects also need to ensure logs do not leak sensitive personal data unnecessarily, because directory attributes can include information that should not be widely exposed. In cloud and hybrid environments, logs must be correlated across services, which requires consistent identifiers and careful time synchronization. When designed well, policy and directory logs provide a coherent story of who requested access, what policy was applied, and what decision was enforced. That coherence is what makes governance and incident response realistic rather than aspirational. It is also worth addressing how these technologies fit into the wider identity architecture without pretending they are the only pieces. LDAP-based directory access is often one part of a broader identity ecosystem that includes sign-on flows, session management, and lifecycle automation. XACML-based policy evaluation is often one part of a broader authorization approach that may also include role-based access control, attribute-based access control, and service-level checks. The architectural skill is knowing when to use centralized policy evaluation versus when to enforce decisions locally in the application. Some decisions require deep business context that only the application has, while other decisions can be standardized and centralized. You might centralize policies for common actions like accessing categories of data, while leaving detailed workflow decisions inside the application, as long as the application still respects the policy boundaries. Beginners sometimes try to centralize everything, which can create complexity and performance issues, or decentralize everything, which creates drift and inconsistent enforcement. The mature approach uses centralization where it improves consistency and governance, and uses local enforcement where it preserves correctness and context. Through that lens, LDAP and XACML are not competing solutions, but complementary tools in an architecture toolbox. As we bring these ideas together, it helps to remember that enforcing authentication and access policies is not a single control, but a chain of dependent controls. Identity attributes must be correct and timely, which means lifecycle processes and directory governance matter. Policy logic must be clear, reviewed, and consistently evaluated, which means policy management and change control matter. Enforcement must be reliable and resistant to bypass, which means integration and error handling matter. In cloud-connected environments, these dependencies become more visible because services are distributed and because identity is often the primary control layer replacing traditional network boundaries. LDAP supports the consistent retrieval of identity and group data that many systems still rely on, while XACML supports consistent, expressible policy decisions that can be applied across services. If you treat either one as a magic solution, you will miss the surrounding design requirements that make it effective. If you treat both as parts of a coherent design, you can build systems where authentication and authorization behave predictably, are easier to audit, and are safer during change. That is the mindset an ISSAP learner is trying to develop: clear trust boundaries, dependable sources of truth, and consistent policy enforcement. Using LDAP and XACML controls to enforce authentication and access policies is ultimately about building consistency without sacrificing correctness or resilience. LDAP provides a standard way to access directory-based identity attributes that many authentication and authorization decisions depend on, but its value depends on the integrity and governance of the directory data. XACML provides a structured way to express and evaluate access policies centrally, improving consistency and auditability, but it still requires strong enforcement at the point where resources are accessed. Together, they allow architects to separate identity data from policy logic while still connecting them through trusted attributes and well-defined decision requests. The best designs account for performance and caching trade-offs, handle failures deliberately, and maintain clear identity identifiers so policy decisions remain accurate across distributed services. They also treat logging and governance as essential because policies must be provable and directory changes must be traceable. When you can explain how directories supply the attributes, how policies use those attributes, and how enforcement makes the decision real, you are thinking in the disciplined, system-level way that architecture requires.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.